Hello guys, welcome to Kentronics. It's good to be here. I want to say big thank you to all our subscribers and say big thank you to all our viewers. You guys are the best. If you are viewing us for the first time, kindly hit the subscribe button, and if you feel you love the video, please hit the like button. And yeah, today we'll be looking at WAN redundancy. I'm using Cisco routers. I'll also be using the Eve environment, more like the Eve environment is more like a replica of what the real devices are. Yeah, so this is doing it on Eve environment, simulation environment. All right, so WAN redundancy. What scenario whereby you need that is, let's say you have an enterprise environment, or let's say in your home, for instance, you like to have two ISPs around. Mm? So if ISP A fails, you want ISP B to kick in, right? And things like that. We ask ourselves, how do I know when ISP A has failed? Mm? Okay, even if ISP A fails and comes back and it's not so good, how do I tell it to switch back to ISP B? Let ISP B be my primary for now until ISP A is fine and it comes up. So we're looking at the various technologies that can help us to achieve that. And one of such is IP SLA. It's a feature from Cisco that helps us check our network stability based on various parameters like latency, jitter, packet loss. But okay, then we also have we playing around with the default route metric. So let's say put a metric of 20, 10. We'll look into that. We also have track for the IP. You can also create a track for the tracking for the IPSLA, so that you say, if IPSLA fails, to check is did IPSLA did it fail, did it not fail, those kind of stuff. So you can also do that. Okay, if it failed, I want something to happen, so you can use that trap to initiate that. Okay, we're also looking at NATing, I believe, also NATing. Yeah. Also, I've looked at also, I didn't include that, but I also include that in it. EEM script, that's an embedded event manager. I'm not going to really doing much with that, but I'll just show you that. So you will use the tracking feature to initiate the EEM script. So what is EEM script? EEM script is more like I want the router is Cisco routers. I see that on most times. Okay, it allows you to run scripts that are triggered on certain events. So let's say an event happens, and I want something to be triggered once this event happens. So even if I'm not there, the router will by itself to log on to do carry out those set of commands, like as if a user is there imputing those commands. So you'd have said them there. So I want this set of steps or this set of events to happen, or this set of script, this set of commands to run should this event happen. So that's what an EM script is, embedded event manager. So there are lots of things you can use those things for, but I won't be going deep into that. Okay, so for this demonstration I'm using if, which is what I'm using here. I'm running it on my VMware. Okay, so this topology we're looking at, I'm going to explain that. This basically is our internet, simulating our internet environment. This is simulating ISP A, this is simulating ISP B. These are customer router, which are router, let's say a company's router. Then this is our LAN, our switch. So we could also have our APs, access points, on this switch. Let's say this is a PoE switch, right? Yeah. So we have on this router we have a DHCP server. We configure DHCP server on this router. DHCP server on this router. So that's what these systems are picking up their IPs via DHCP. You could look at that for if. So you can see show IP. So you do show IP, you can see it's getting the gateway 192.168.1.1. So I've configured all this beforehand. I don't want to bore you with all the configuration, but what I'm going to do here, I'm going to explain everything in details, what's happening, and I'll also leave a link below to the configuration, to the config file, that's the scripts for each of the devices. So on this guy on the internet, there's nothing much going there. All I just did, let me explain what's happening here. I configured 8.8.8 as a loopback interface here. So the idea is that this guy is on the internet and I would like this guy to be able to reach 8.8.8. That's acting as my internet. This is acting as ISP A, ISP B. There's a static route from here to 8.8. There's a static route from here to 8.8.8. So let me just show you what's running on it. Sure. Nothing much. Let me just show you. So I configured two interface IPs, 8.8.6 and 8.8.2. Yeah, and then we have our static routes from those routers. So IP routes, anything coming from this subnet, because this guy normally he knows this 8.8.1, he knows this guy, but he doesn't know this guy. So I'm trying to, anything coming from here, route it through 8.8.2. So you can see, route it through 8.8.1 or 8.8.5, which it already knows. So if I do show route, show IP route, it has all those routes there. That's by the side. On this side also, I just, nothing serious is going there. I just configured I've configured down the IPs on the interfaces. So just 30.30.2. Nothing much. I have my static route, that's all. On this guy also, all I did, I just configured an IP address on the two interfaces. So show on. Yeah, so on the two interfaces we have the IP address and then one static route. Starts for the 8.8.8 route 8.8.8 via this interface, and then 8.8.8 point it to that guy. Okay, so let's look at this. On the switch side, nothing much is happening there. Okay, so let's look at the router. So I'll do show run. I'm going to explain all the configuration that is happening here. So the first thing first we are going to do, if we want to achieve this kind of thing now, is note I said we are going to use IPSLA. We're going to do NATing. We're going to do create track. We're going to do and play around with our default route. So let's go to customer router. So this is the configuration. First and foremost, configure this IP parameters on this interface. It's 30.30 on this interface, 5.5 on this interface, this on this interface. So once you're done with that, we'll come and create IP SLA. So if you look here, yeah, so IP SLA 1. So this one you are testing for ping. I'm not doing jitter or anything. I'm just testing for ping. IPSLA echo 30.30.2 source IP 30.30.1. So when I say ICMP echo, so I wanted this interface, this router is going to ping this interface. So let's say this guy is the gateway. Let's say, you know, when you have an ISP now, when they give you a service, they give you the IP you should configure your interface, and then they tell you this is the gateway. So the gateway is going to be, for that service, going to be 30.30, 30.30.30.2. Going to be your /30 is going to be your gateway for this service for ISPA. So you are going to, in configuration, when you are configuring it, you say, oh, ping okay, ICMP echo 30.30. That's the gateway source IP from this interface. Why? Because I've configured this IP on this interface. Even if I do my default route, I create a metric. I say, static route has a default metric of 1. If I create a metric of 10 and 30, and then the second one for the second ISP maybe create 30, it won't automatically switch over. Why? Even if this ISP is down. Why? Because this IP is configured on this interface. It will only switch except if this interface should go down, and there's no way this interface is going to go down except this router goes down, which is very unlikely. So how do we know when this ISP is down? Again, note also in some situations, also in real life scenario, I might be able to ping my gateway, but the internet service is down. So most times what do? We say, I'm actually going to be pinging this 8.8.8 in real life. I can be pinging, I'm going to ping Google DNS. Then I'll now say if it should fail, if reachability fails, that tells me that ISPA is down. And if ISPA is down, ISPB should kick in. That's the whole summary of what we are doing. And again, what I'm going to do now is that, so if ISPB kicks in, ISPB should become, this 5.5.5.2 should become my default gateway. If ISPA should come back, my default gateway should change to 30.30.30.1. Do you understand? Okay, so I've explained basically what's happening. So looking at the router's configuration now, we configure IPSLA 1. So if it were to be in real life, I'll do ICMP echo 8.8.8.8 source IP, that my interface IP for IP, what I configure on that interface for ISP1. Then frequency, the default is 60, that is 60, that's 1 minute. But I want to do something more, so I configure 15, which is 50 seconds. Every 50 seconds, be checking it. Every 50 seconds, be checking. Then IPSLA schedule lifetime forever, so it starts now. So that's just it. Then I do another one. Okay, I already created one, so good and fine. Second thing I did, I created a track for it. So I did track 15 IPSLA. So this guy will always check if IPSLA 1 is reachable. Track 15 IPSLA 1 reachability. So if I do show track 15, this tells me IPSLA 1 reachability is up. Tells me. So if I do show IPSLA statistics, this tells me, oh, little operation, number of successes. This just tracks it, number of failures. But if I really want to know whether it's, or you can check from here when last it incremented. But if I want to check that reachability, this track helps me to know, oh, if it's up. Again, this track is also what you use in your EEM. Okay, this one will tell you, oh, it is down. If I switch it down now, it tells me, oh, this guy is down. If I switch it up now, it tells me that it's up. So if I go over here now and from ISPA now, I switch off this interface, shut down this interface to see. So let me go over to ISPA. The interface G01 bar. ISPA. Interface G0/1. If I shut it down. So I've shut it down now. If we count up to 50 seconds, you find out that my gateway now is switch over. So if I do show IP route, my default gateway 00. This is default gateway is via 30.30.30.2. As seen here is via this guy. So what will happen now is that based on what I've done and using that track, my gateway is going to switch over to 5.5.5.2. So I can do show. It hasn't checked it because it does it every 50 seconds. So 50 seconds. So you can see now 50 seconds say tracks 15. IPSLA 1 reachability up, down. That's why I named it. It's down. So if I do show track 15, reachability is down. It's tracking IP SLA. So I say show IP SLA 1 statistics. Show statistics. So number of failures has incremented. If I do also show IP route, remember I told you guys before, this was my primary default gateway. But once this guys go down to switch over to this, so let's see. Show IP route. Oh, sorry. Show IP route. You see, I've switched my IP, so everything is via this. So if I'm on, I just want to show you what's up. So if I'm pinging, I can ping 8.8.8. It's going. So if I search trace 8.8.8, okay. I'm not sure how, but let's check from here. I do trace route 8.8.8. So this will give me all the hops. I'm testing doing my trace route now from the switch. So it should give me all the hops that so 192.168.1.1.1, that is the router. That's this guy. 5.5.5. So this tells me it's going through this guy. Yeah. So what's the next one? 8.8.8.2. This tells me it's going through this part to get to 8.8.8. That's all. So right now, so let me switch back. I'm going to bring up this interface. Let's see, the service came back up again. Let me bring up this interface, ISPA. So I do no short. So it's up. So let's give it a while. You find out that after I've not fully explained what's going on, so but I'm just trying to give you a full picture of what's happening on the IPSLA part of things, and then the tracking of a thing. Why the tracking is very important, because it's that track I'm using to manipulate my default route. That's the main thing I need to learn. Then I'll go into NAT for those that don't understand, so you understand what I'm, because I'll explain NAT, what's happening on the NAT side once I'm done with it. So if you do show IP route, it's still going through 5.5.5. So till the IPSLA has checked again, and it's every 50 seconds. Show IPSLA, still it hasn't switched yet. So let's say show track. It's still down. Let's give it a while. True. Okay, so let's see. Okay, you can see now reachability is up. I was just checking the interview, so reachability is up. So now let's do show IP route. It has switched back to 30. So if I come to this switch now and do this again, let's watch and see. So you find out that it's going to take this part now. I'm going to go from here to here to here. to here, then before it hits 8. So you can see it's passing 30.30.2. So where do we have that? We have this here. This first hop, second hop, third. Then it hits 8.8.6. Where's 8.8.6 here? So that shows you that this works. Okay, so that's the major thing that's happening here. So let me now explain to you how that works for us. Let's go. Let's do show run. So let's show you ahead what's happening. So I've finished. Let's say I've configured my interface, the IPs on the interfaces. I've configured my IP SLA based on what I've configured. A track for it. So what's the next thing for me to do? The next thing for me to do is that I'm going to do nothing. So that taking for instance, assume that you all already understand what NATing is, but we're going to look at NAT. There are different types of NAT: static NAT, dynamic NAT overload. So, but what we're doing is NAT overload. Static NAT is when you map. If you don't understand what NAT is when you are trying to map an IP on one side to another network. Do you understand? Okay. So let's say for instance you have two companies that okay, let's say you're running an enterprise environment, right? And let's say company A is using their LAN subnet, let's say 191.168, or they're using 172.29.8/16 subnet 172.29, and also you in your LAN you're using 172 dot something in your LAN subnet, and you guys need to do an interconnection or pairing together. I maybe say it's a subsidiary of your company, right? And you guys maybe need to do a VPN to you or something. So in that kind of situation, what do you do so as to avoid issues? What do? You do NAT. You do a NAT in your network. I'm not going to go into details on that. We're going to do a NAT. Let's say we have two different companies coming in together, and they already have that is a subnet that they are both using. So if they still want those things to communicate with each other, let's say data coming from that other network coming to my network is going to NAT to an IP that I've given for it to come into my network. Let's say I want you to change to 191.168 when it's coming into my network. I could also do part for it, depends. So there are modules, but in this scenario, I'm going to explain something. I can also do that. Oh, let's say on my public IP side, I have maybe a pool of /24. I could say, okay, I could say, oh, for each user, let's say each user IP, every IP gets as if NAT to a public IP, but that's very expensive and that's waste of public IPs. And that people can say, oh, I buy a /29 from my /29 subnet from my ISP, and that will now give me let's say 6 usable IP. So I I I now do a dynamic NAT in that I have a group of public IPs that I want to be NATing to the internet. That's doable. Our telcos do that. But in this case, I just have only one IP. So what I'm going to do is NAT overload part, right? So it's port based. So go and read up on it. Go and read up on it. I don't want to go into that. I can do a whole video on that. But that's nothing. So I'll show you the configuration. I'll explain to you line by line what's happening there. Okay, so on the NAT side, first thing first, I'm going to do NAT inside. So this our LAN segment is our inside leg. This other segment is our outside leg. Do you understand? So I'll do NAT, configure NAT inside here. Anything going outside, the outer side is going to be NATing outside. Please read up NAT to fully understand what I'm saying. So NAT inside, this is my LAN. This other side, connection to ISP, NAT outside, IP NAT outside. This other one, IP NAT outside. So when I come here, So when I come here, I will do, so I did a route map. So on a normal day, if you come and say you want to configure NAT for two different interfaces, it won't work. That's it. Well, for me it didn't work, so that's why I did a route map. So in normal NAT, what you do, you configure your NAT inside the interface and NAT outside the interfaces. You're going to create an access list that will permit that your LAN subnet, your specified subnet, to pass through. Then thirdly, I'm going to do the statement stating whether it's NAT overload, or if it's dynamic, create a pool. It's not overload or static, whichever one. So since I'm doing over the IP NAT inside source, I would have created source route map ISP map. That, so this map, this route map now, that's what I use because I want to, if I have, let's say, a third ISP, I'll create a third route map for it. That's the beauty of route map. I can have up to 5 route maps. And that thing you can also do, load balancing, but I'm not looking at that today, amongst your different ISPs. Or you could just do failover amongst them. So I come here, I do match IP address. This IP address 110 is my access list here. This route map B ISP B map permit 10. So this, so 10 is the same route map. So match IP address 110, that is, I mean access list 110, that's what it is. Match IP address, that IP address is this access list. So match interface gigabit 00. This 00 is the interface for ISP B. This is the interface G01, interface for ISP A, as stated here. Please ask questions if you don't understand. So I'll configure, so I'll come here and write IP NAT inside source route map interface gigabit ethernet 0/1. But if it were to be without the route map, let me show you in config. So I'll say IP NAT inside source. If you come here, so you can do source static. Static means you are doing it one-to-one. If you have route a particular LAN IP, let's say whatever this one is, 192.168.1.2, to a specific public IP. If I say dynamic, that means I have a pool of public IPs I want my subnets to be NATing to. But if I say paths, that says I do a source static or source list. Okay. Access list number, source list. So source list, sorry, source list 110. That is 110. Then interface. So I'll now configure. Sorry, I mean the source list is your access list. Source list 110. Then I configure the interface, let's say interface G00, G01. So this is going to be the case, but you find out that you cannot configure two of these. You can only configure it once for one ISP. If you want to configure for a single ISP, you won't be allowed to do that. So that's why you need, I'm just going to show you, you need the route map. So that's why you need the route map. So with route map, to just be checking all these criteria, they're still all like one. You use this route map most especially when you are doing policy based routing and all that, but I'm not going into that. So for this specific specification, I'm going to be using route map for this. Okay, so the second part is that, okay, if I've configured NAT and everything, I still need to configure my default route. So where do I need anything I don't know in my subnet? I'm looking for it to it, where should it route through? So that's the major place, that's the major thing that comes into play. Without this, we'll still be having issues. So I'm coming here to configure, I'll come here and configure. I'll come here and configure default route IP route 0.0.0. That means any IP, any subnet. You should route it through 30.30.30.2, and then you now come here and put track. This track, I told you, is what checks for the reachability of this IPSLA1. And that IPSLA1, let's say for instance you are testing, you are using that source interface to ping Google DNS, let's say 8.8.8. If it should fail, IPSLA track, this track 15 will show you failed, it will display failed. So now it's not more like a program, like conditional statement. Say, oh, if this guy fails, metric. So this like if this guy is showing failed, this guy will pick him. Because without this, there's no way to report failed. So further, as far as that interface is up, it won't report failed. Do you understand? Please, if you have any questions, drop it in the chat section, in the comment section. Yeah. So that's that on that. Is there any other thing I'm missing? Okay. So that's that on that, and we are good to go. So I'll drop this the script in the comment section. Okay, and that thing I said I'm going to touch EEM script. So what's EEM script? EEM is embedded event manager. So I'm going to give you a brief discussion on how the EEM works. So we say, let's say event manager applet. So there are two types. There's event manager applet. There's another one that you have to configure. You type the script manually. I don't know about how to use that one for now, but the applet one is the straightforward one that I've used. So say ISP. So what I'm going to do, I'm going to just do clear IP NAT translation. So there are some scenarios whereby you have to clear your IP NAT translation, maybe troubleshooting, maybe it doesn't clear when you're switching over to the next ISP. So just to prevent any issues. But let's just write on side ISP1. So what do I do as an event track? So this way again the track, this thing comes to play again. Event track what? Track event track 10. No, our track was what? Track 15. Let's do state. So what state? If so, now I'm tracking that IPSLA track, IPSLA1 track 15. IPSLA1 track 15 is monitoring IPSLA1. So if IPSLA1 should go down, track 15 will notify me. You understand? So I'm saying state down. So if this guy should go down, I want it to do these following steps. Do you understand? I'm now going to do, okay, action, call it 1.0. Okay, let me know. Action what? 1.0. How is it going to log in? CLI. What command do you want to impute? Put a string. I'll put enable. So I told you it's like as if someone is manually coming to type. Like as if someone is there imputing everything. I'll come 2.0. I can come, what's my password for my, let's see, my password is Cisco. Well, this guy don't have any password. So I'll just come, put my command, clear IP NAT translation. If you make a mistake here, it's not going to work. Then first. Do you understand? So this comes in if that track reads down. And again, we can also do again another one for if it reads up, so that it clear NAT translation for ISP2, so that ISP1 will kick in properly. So I'll do exit. So ISP2. So come again. So state up. So if it is up, that's IPSLA1 is now able to reach, let's say 8.8.8.8, or in this scenario we used 30.30.30.2. So state up. So what do I want it to do? I'm going to say enable. First thing it's going to do, enable, like when you log into your Cisco router, what's first thing? Even when you are consolidating, it's first thing enable prompt pops in. Put your enable password, but there's no enable password for this. So then I come in and then I put clear IP NAT translation first. That's that. Right. Okay, so that's that on that. I believe I want to say thank you for viewing, and I believe you've been able to learn something new. Kindly share your feedbacks and comments, and I will ensure to reply. Thank you all very much.